Okay, everybody, welcome to our review. We're going to go through our Unit 6 study guide. This here will be the key that I will post when we are all done. So let's go through a few things here. All right, we need to define and write an example of each of the following terms. So molar mass is the mass of 1 mole of a substance. For instance, 1 mole of carbon is 12.01 grams. You have to have units of grams when we're talking about moles, and I just pulled that right off my periodic table from right there. A conversion factor. This is a ratio we use to convert one amount to different units. For example, 1 mole is 6.02 times 10 to the 23rd particles. And so that's how I would set up this ratio there. 1 mole of whatever it is, whatever this happens to be, over the number of particles. Okay? Percent composition is the percent of each element in a compound by mass. For instance, water is 18 grams per mole, and the hydrogen here is 2 grams per mole, right? And so I have 2 over 18 times 100, right? So if I turn my calculator on here, 2 divided by 18 times 100, 11.1% is hydrogen. Okay. The empirical formula is the smallest whole number ratio of elements in a compound. For instance, hydrogen peroxide is H2O2. This is the molecular formula. Right, if I want the smallest whole number ratio, then HO is my empirical formula. Okay? And again, this is the actual number of elements in a compound. Like our previous example, H2O2 is my molecular formula. Okay, that's page 1. Get that out of the side. All right. Now, I need to calculate the molar mass of the following elements, compounds, and molecules. All right, so I'm going to make extensive use of my periodic table here. So, indium. Indium is this element right here. It is got a number here of 114.8 grams per mole. That's its molar mass. Molybdenum is down here. It's 95.95 grams per mole. Okay. And mercury, all right, this is Hg2, so it's going to be twice this. So mercury here is 200.6 grams per mole, but I have 2 of them, right? So this is times 2, right? Plug that in, right? 200.6 times 2. Enter 401.2. 401.2 grams per mole for mercury 2. All right, phosphorus. Phosphorus is here, 30.97 grams per mole, but I have 4 of them in this, so I have to multiply this by 4. All right, so 30.97 times 4, 123.88 grams per mole. Okay, let's take a look at the next one. Okay, now I have to actually do some work. I have aluminum sulfate, so I have aluminum, that's 26.98 grams per mole, and I have 2 of those, so I multiply that by 2. See number 26.98 times 2. All right, that's 53.96 grams. I have sulfur next. Sulfur here is 32.07. 32.07 grams per mole. I have 3 sulfurs there. I'm going to multiply that by 3. So 32.07 times 3. That's going to be 96.21 grams. And then I have oxygen. Oxygen here is 16 grams per mole. And here I have 3 times 4, right? Because there's 4 for each of these sulfates, and I have 3 of those, so that's 12. Right, so 16 times 12 is 192 grams. All right, so my aluminum sulfate will be the sum of all those. So I have my answer plus, go up and grab that, plus, grab that, so I have my oxygen, my sulfur, and my aluminum. Enter 342.17 grams per mole. Okay, now let's do this last one here. I have calcium chlorate. Calcium is over here, that's 40.08 grams per mole. And I'm going to multiply that by 1 just because I have to do this for everyone, so just to make it easy. So this is going to be 40.08 grams per mole. Then I have 2 chlorines. There's 1 chlorine in each chlorate. So chlorine here is 35.45. 35.45 grams per mole times 2. All right, so plug that in here. 35.452. Wait, sorry, times 2. 70.9 grams per mole. And then I have oxygen, 16 grams per mole. In this case, I have 3 oxygens in each chlorate. I have 2 of those, so I have a total of 6 oxygens. Right, so 16 times 6 is 96 grams per mole. And then I want to add all those up to get the total. So I have 96 plus 70 plus my 40. I guess I can just write that one in. 40.08 from that equals 206.98 grams per mole. That's the molar mass of calcium chlorate. All right, number 2 done. All right. Now, I'm going to make use of some of this from the previous page, okay? The calcium chlorate that I just weighed here is 206.98. 206.98 grams per mole for the calcium chlorate. So I'm going to make use of that. Right? I want the percent composition of calcium. Well, calcium, I have one of those, and we saw that that's 40.08 grams per mole. Right? That's the mass of my calcium, right? Because I only have one of them, so I need one. The mass of the whole thing is this, 206.98 grams per mole, right? Times 100 will give me the percent composition. 40.08 divided by 206.98 times 100, 19.4%. Right? Now this one's more tricky. I want the percent composition for each element in sodium hydroxide. So we're going to have a little more math to do. Right? My sodium is 22.99. But I have one of those. I have an oxygen at 16. Right? I'll label these here. That's my sodium, that's my oxygen. And then I have hydrogen here, 1.008. Right? And these are grams per mole, and grams per mole. My total NaOH is the sum of those. So 22.98 plus 16 plus 1.008, right? 39.988. 39.988 grams per mole. So to find each of these, I take the part over the whole times 100. So for sodium, we have 22.98 grams per mole over 39.988 grams per mole times 100. Right? Make sure that says mole. For oxygen, I have 16 grams per mole over 39.988 grams per mole times 100. And for the hydrogen, I have 1.008 grams per mole over 39.988 grams per mole times 100. Right? And then let's plug these into our calculators and find out what this is. Okay, 22.98 divided by 39.988 times 100 is 57.5%. And the oxygen, 16 divided by 39.988 times 100, 40.0%. And then 1.008 divided by 39.988 times 100 is 2.52%. Right? Really, I'm going to round that. 2.5%. Okay, and then that all adds up to 100, so we're good. All right, what's the percent composition of hydrogen in HCN? Well, hydrogen is 1.008, carbon is 12.01 from here, nitrogen, right, there's 12.01, nitrogen is 14.01, right, the total, if I add those all up, right, 1.008 plus 12.01 plus 14.01, right, 27.028 grams per mole total. Right, I want the hydrogen, so I just need the 1.008 grams per mole divided by 27.28 grams per mole. Oh, forgot the 0.028. Right, times 100 equals 1.008 divided by 27.028 0.028 times 100, 3.73% hydrogen. Okay. Now, I want the percent oxygen in H2O2. So again, hydrogen is 1.008 grams per mole times 2. Oxygen is 16 grams per mole times 2. Add those up to get the total. All right, so 1.008 times 2 is 2.016. 16 times 2 equals 32, right? Plus 2.016, right? 34.016 grams per mole. So I want the oxygen. So for oxygen, I have 32 grams per mole divided by 34.016 grams per mole times 100. 32 divided by 34.016 times 100. That's 94.1% oxygen. Okay. Let's do the next one here. What's the percent composition of nitrogen in NH4Cl? Okay, so let's get this up here. Nitrogen is 14.01 grams per mole. Hydrogen is 1.008 grams per mole, but I have 4 of those, and chlorine is 35.45 grams per mole. Okay, so let's add all these up. 14.01 plus 1.008 times 4 plus 35.45 equals. So that's 452.944 grams per mole. Okay, I want the amount that's nitrogen. That's my nitrogen, 14.01 grams per mole divided by the total, 452.944 grams per mole times 100, right? 14.01 divided by 452.944 times 100, 3.09% nitrogen. Okay, that's page 3 done for us. Okay. Now, we're going to go ahead and break there. We'll take a stop, and then we'll move on to the next page in the next video.